Hello everyone, welcome to the series of videos on Big Data and Hadoop. In this series, we are going to cover the following topics. We are going to start off by introducing you to what is Big Data and talking about why is Big Data important. We will then look into technology solutions that will help us solve big data problems, and we will start that topic off by talking about why relational database management systems cannot always solve all big data problems. We will then discuss one of the alternatives to RDBMS, that is NoSQL database systems, followed by an in-depth discussion about one of the most talked about technology innovations in recent times, which is Hadoop. We will then discuss in detail about the core components of Hadoop, the Hadoop Distributed File System or HDFS, and MapReduce programming paradigm. We will conclude by introducing you to some of the other important sub-projects within Hadoop, such as Apache Hive, Pig, HBase, Scoop, and Flume. In today's video though, we are going to introduce you to big data, discuss the characteristics of big data, and most importantly, highlight why is big data important. So, what is big data? There are many definitions floating around. Let us discuss a couple of them here. Here is the first one. Data becomes big data when the individual datum stops mattering and only aggregates or derived analysis matter. Now, what does this mean? Well, according to this, transaction records like the transactions you do in a bank are not big data. Not that they can't be large. There can be trillions and trillions. But here, each transaction likely matters, meaning they have to be stored and treated in a way that preserves their integrity and in a way that each one can be accessed individually later. It's just that it's a whole lot of data. On the other hand, we have, say, sensors that are used in various fields and produces lots of data. It is still trillions of things, but it is unlikely that you care to ever retrieve, say, the temperature at 8:43 a.m. on July 2nd, 2010, from a particular sensor, do you? I don't think so. But what you do care about is detecting and recording irregularities. You do care about things like average power consumption, trends, etc. Aggregates and analysis are just about all that matters and not the individual reading. Now let us take a look at another definition. Big data is a buzzword or catchphrase used to describe a massive volume of both structured and unstructured data that is so large that it is difficult to process using a traditional database and software techniques. So here the keywords are massive volume, unstructured, and data that is difficult to process using traditional techniques. So there you see multiple definitions of big data, and all of them makes sense. Now let us look at a couple of examples of big data. Every second, consumers make around 10,000 payment transactions worldwide. Every hour, Walmart, a global discount departmental store chain, handles more than 1 million customer transactions. RFID systems generate nearly 1,000 times the data of barcode systems. And we have not even talked of social media like Facebook, Twitter, etc. So there is so much data to analyze. Big data is both a promising and emerging avenue for productivity and innovation in today's competitive arena. Let us see how the systematic study of big data across sectors and geographies can yield results and provide advantages. Let us take the example of smart cities to elaborate on this. To help them deal with the consequences of their fast expansion, an increasing number of smart cities are indeed leveraging big data tools for the benefit of their citizens and environment. The city of Oslo in Norway, for instance, reduced street lighting energy consumption by 62% with a smart solution. And the Memphis Police Department in the United States started using predictive software in 2006, and since then it has been able to reduce serious crime by 30%. The city of Portland, Oregon used technology to optimize the timing of its traffic signals and was able to eliminate more than 157,000 metric tons of carbon dioxide emissions in just 6 years, which is basically the equivalent of taking 30,000 passenger vehicles off the roads for an entire year. If we are able to analyze user behavior and their preferences, we can make personalized recommendations for every individual, such as which news articles should I read of the thousands that I come across every day? How do I choose a book of the millions available on my favorite sites or stores? And those are just a few of the most spectacular examples. In order to come up with insights like the ones we just talked about, and of course more, companies need to be able to apply technology to study and analyze the data to understand it. But before being able to come up with such analysis, they will first have to acquire data, and typically they come from primarily two types. Internal sources such as organizational or enterprise data, external sources such as social data. The internal sources basically provide structured or organized data that originates from enterprise and helps run businesses. Examples include customer relationship management, enterprise resource planning systems, customer data, sales data, etc. Whereas external data sources provides unstructured or unorganized data that originates from the external environment of an organization, such as business partners, syndicate data suppliers, internet, the government, etc. While internal data is primarily used to support daily business operations of an organization, external data sources are often analyzed to understand the competitors, market, environment, and technology. Now, let us move on and talk about some of the characteristics of big data. They are primarily volume, velocity, and variety. Let us talk about the first one, volume. Well, this is the most obvious one, isn't it? Because we have been harping on it for a while now. We all know the volume of data is increasing and increasing exponentially. You can understand this quite simply by comparing the size of your typical text file with that of a typical MP3. Take this forward and compare these sizes with video files. Lastly, take it a step further to look at the size for what is now a standard with all of us, that is high definition videos. As you can see, the increase in size is pretty dramatic, from kilobytes to megabytes to gigabytes. This also means that the volume of data being collected at any place increases significantly. But that's not the only thing that drives volume. Sources of data have increased significantly as well. Take as an example a typical cell phone we carry around. Not so long ago, the only data it had was voice calls and texts. With the advent of smartphones and the mind-boggling array of sensors and other equipment within them, the amount of data they carry is staggering. Combine this with the internet explosion, social media, digitized businesses, e-commerce, GPS devices, and now you will begin to understand why it's not only the size of individual files that are driving data volumes in today's world. Moving on, let us talk about velocity. This is probably the least understood of the three V's. There are multiple angles to look at velocity as a dimension in which data is expanding. First, it is the sheer rate at which data is coming in. For instance, Facebook's approximately 950 million users generate approximately 2.7 billion likes on Facebook per day, or 400 million new tweets are created by users each day. That's a lot of data coming in super quick time. And secondly, it's just not the rate at which data is pouring in. It is also how quickly it needs to be processed. Batch processing is no longer good enough. Business managers need data in real time. Sometimes 2 minutes can be too late. For time-sensitive processes such as catching fraud, big data must be used as it streams into your enterprise in order to maximize its value. You might have to scrutinize 5 million trade events created each day to identify potential fraud, or maybe analyze 500 million daily call detail records in real time to predict customer churn faster. And thirdly, data is only useful as long as it is being processed faster than it is entering the systems. If the velocity of data processing is less than the velocity of data entering the system, all you would end up with is an ever-growing backlog. And of course, because the demand is for real-time data, backlogged information is not really of use to anyone. And finally, let us talk about the last characteristics of big data, which is variety. Today, data comes in all types of formats, and they can be primarily classified into two types: structured and unstructured. Structured data can be defined as a set of data with a defined repeating patterns. It first depends on creating a data model, a model of the types of business data that will be recorded and how they will be stored, processed, and accessed. Such a pattern makes it easier for any program to sort, read, and process the data. Some sources of structured data include relational database management systems, flat files in a record format, or multidimensional databases, and even legacy systems. In a complete contrast to structured data, unstructured data refers to information that does not have a predefined data model. Unstructured data is typically text heavy, but may also contain dates and numbers as well. This results in irregularities, which makes it difficult to understand using traditional computer programs as compared to structured data. Some sources for unstructured data include unstructured text internal to an organization, such as documents, logs, survey results, and emails within the organization's database and data warehouse. Whereas data from social media comprises data from social media platforms including YouTube, Facebook, Twitter, LinkedIn, and Flickr. New insights are found when analyzing these data types together. Like, you can monitor hundreds of live video feeds from surveillance cameras to target points of interest, or sentiment analysis of brands or products based on user reviews on social media such as Facebook and Twitter. Managing, merging, and governing different varieties of data are some of the issues many organizations still struggle with. As you see, big data is more than simply a matter of size. It is an opportunity to find insights in a new and emerging types of data and content, to make your business more agile, and to answer questions that were previously considered beyond your reach. Now, let us take a look at where the sources of big data stand on the variety and volume scale. The y-axis represents the volume, whereas the x-axis represents the variety. You notice that an ERP system usually generates data in megabytes to gigabytes range, whereas a CRM product is in the range of gigabytes and possibly terabytes. Sensors, RFID devices, etc. are some of the sources that generate data in petabytes. Something you should also take notice of is that one of the most prominent source generating data in the petabytes range is user generated content on the social media, which explains why the internet is such an important source for big data. So now we have talked about what is big data, its characteristics, and also the sources of big data. But the most important question remains unanswered. Why is big data important? We have spoken about this previously as well, but let us try to reinforce the point by applying another context to big data. In this era of data, the success of a company not just lies in how good they are at their core business, be it selling a product or a service, but also at how well they can analyze their data and related data around them to derive insights about their company, their competitors, etc., and as a result derive growth from it. As an example, let's say as a consumer yourself, you have so many options to go shopping. Let's say you want to buy a bicycle. If you were in the US, you have Walmart, Kmart, and Target among others as your options. The first thing most of us do is to compare the prices. So you will probably visit each store or use a mobile application that compares data from various sources. You probably would have noticed that the price of the product will almost be similar. Every business wants the customer to go to them, so they will invariably offer the same price or lesser than their competitor. So price-wise, most retailers are similar. So what drives you, the customer, to pick one retailer over the other? For companies, this is where the importance of data comes in. You may ask how. Let's say, for example, by gathering the footprints left by you on the internet, companies can reach you before you reach them. That is, they can probably guess that you are also interested in bicycles because maybe you tweeted about high gasoline prices and also liked the picture of a new eco-friendly bicycle on your friend's Facebook wall. This is what data can do. When applied correctly, it helps companies reach customers more effectively than others. Now you might ask, how is this big data? Good question. In our bicycle example, the tweet represents unstructured text, and the picture on Facebook is a JPEG or GIF image. This represents the variety dimension of big data. Now imagine you have to do this for a whole range of products and the endless number of internet users. The data gathered will be huge. This represents the volume. Now, for the company to be successful, they have to reach the customer before their competitor does. Sometimes this needs to happen in real time. This is the velocity dimension of big data. How fast you generate data and how fast you analyze the same. Handling the three V's together harmoniously results in what some in the industry refer to as the fourth V of big data, which is value. So what we talked so far refers to an area called big data analytics, which is the complete process of collecting, organizing, and analyzing large amounts of data to gain insight. Most organizations today consider data and information to be their most valuable and differentiated assets, next only to their employees. By analyzing this data effectively, organizations worldwide are now finding new ways to compete and emerge as leaders in their fields, to improve decision making and to enhance performance. At the same time, with the volume and variety of data also increasing at an immense speed every day, the global phenomena of using big data analytics to gain business value and competitive advantage will only continue to grow, as will the opportunities associated with it. In short, big data analytics is an exciting field of work with constant improvements almost on a daily basis. and like everything else in life, it is a very challenging journey as well. We would like to take you through the first steps of this journey in the best way possible. So get ready, because we are ready. With that, we come to the end of this video. And just to do a quick recap, we talked about what is big data, its advantages, and why it is important. And in the next video, we will discuss about the technology solutions for big data and why relational database management systems are not always suited to solve big data problems. Thank you for watching and stay tuned.